Sine of 5 pi over 4. So they're giving it in radians. And radians don't really mean much until you've had a lot of experience with them. But now, maybe if you know divided by 4, that's going to be some kind of a 45. Divided by 2, that's some kind of 90. Divided by 3, so it's 180 divided by 3. Some kind of 60, 180 divided by 6. Maybe some kind of 30 degree. So here we go. Your ratio, you know that 2 pi's is 360 degrees, and that is in the unit circle. That is when your circle has just a radius of 1. So the circumference all the way around the circle, a full spin of 360, is going to measure in length 2 pi. So we're going to simplify that, and we're going to go 1 pi is 180. So every 180 degrees is 1 pi. So if I've got 5 pi's over 4, it's like I've got 5 180s over 4. So we're going to times 5 by 180, divide that by 4, and that leaves us with 225 degrees. So 180, if you just divide 180 by 4 by itself, that is where we're getting the 45. So 180 divided by 4 is 45 degrees. So anytime you have a pi over 4, that's some type of a 45 degrees, because 180 divided by 4 is 45. So I'm going to have 5 of these 45s. So if I have 5 45s, there's 1 45, 2 45s is 90, 3 45s, 4 45s, 5 45s is down here. So 225 is more than 180 but less than 270. But if you just count by 45s, you're counting 5 of the 45s. So you go 1, 2, 3, 4, 5. Okay, so now I'm going to do some trig. So I am going to go up, and that angle I know is a 45. That angle is a 45. That's a 90. And I know that it comes from a square. So you can draw your own shape, draw the box. If you've done it enough by now, maybe you don't need to. Make up your own dimensions. I'm going to choose a 2 by 2 by 2 by 2, and this middle is going to be 2 square roots of 2. Now this piece right here is negative because it is going left of 0, and this piece also is negative because it's going below 0. And your hypotenuse, that's what you're spinning. That's like the radius of my circle. And it is always positive. Your hypotenuse is always positive. The only ones that are negative are the ones on the x-axis to the left and the ones on the y-axis below. So we are doing trig from this angle right here. So that means this is opposite, this is hypotenuse, this is adjacent, and I need sine. So I need opposite over hypotenuse. So negative 2 over the hypotenuse is 2 square roots of 2. And now I'm going to start simplifying the fraction. That is, I'm going to simplify to 1 and 1. And you can't leave a radical on the bottom. So I'm going to times the bottom by square root 2 times top by square root 2. So on top I got negative square root 2. On bottom I've got square root 4, which is a perfect square. So we got negative square root 2 over 2. So bottom, you can never leave an irrational number. You got to turn it to a rational number. And that's it. Now you can check on your calculator. On your calculator, if you type in sine of 225 degrees, sine 225 degrees, hit enter. That is a negative 0.7071067. And if I type this fraction in on my calculator, they want the exact. They do not want you to round some decimal. So no decimal. Don't give a decimal, because this decimal is irrational. It's a square root nasty number that's you're going to have to round. It never ends. So you're going to have to round it. If they want the exact, they want the fraction. So if you type in negative square root 2 divided by 2 that is the same decimal. Negative 0.7071067. So these on the test, you can check real quick to see if your work is correct. So these you can get 100%. Okay, tangent of a negative 11 pi over 2. So I know that every 180 is 1 pi. So if I divide 180 by 2, that is 90 degrees. So this is a negative 11 90s. So there's 190, 290s, 390s, 490s, 590s, 690s, 790s, 890s, 990s, 1090s, 1190s. It's going to stop right there. So negative 11 times 180 divided by 2 in degrees. Let's see if we match up. That is a negative 990. And I'm going to minus 360. Okay, the negative just means direction. I'm going to go clockwise. So I'm going to just do 990, take away 360, and that leaves me with 630. Take away another 360. So if I take away another 360, that is 270. So I should do 2 full spins, which, let's see what I got here. I got 1 full spin, 2 full spins, and then go 270. So there's 90, 180. Okay, that matched up. So radians, hopefully you're starting to get pretty good with radians. Now, if it ever lands on one of these lines, on the y-axis or on the x-axis, you cannot drop vertical and make a triangle. So we have no adjacent piece, we have no x piece. So if it lands on a line, they're the easiest. Just do them on your calculator. So I'm going to punch in, you have to punch in this tangent of a negative 990. So on your calculator, type in tangent negative 990, and it says undefined. So this is no solution. Okay, pi thirds, a third of a pi. So 180 divided by 3, a third of 180 is 60 degrees. 60 degrees are kind of hard to count by. 45s are easy, 90s are easy, 60s are a pain in the butt. So if you're going to count by 60s, and that's a lot of them, that's too many to count by, so let's just do this instead. Let's go negative 14 pi, and every pi is 180 degrees divided by 3. So if I do a negative 14 times 180, divide that by 3, that is a negative 840. So let's do this. 840. I know 720 is 2 spins. So if I take away 720, that leaves me with 120. So I have got to do 2 spins, and it's negative, so I gotta go this way. Alright, there's 1 spin, 2 spins, and now I gotta go 120, and 120 is like right there. Okay, so I'm gonna go vertical and make a 90, and that much right there is 120. So this much in here has to be 60, because it's got to make 180 a straight line. So I'm just going to do 180 minus 120. And there is my 30, and I know my 30, 60, 90 comes from an equilateral triangle. I'll call it 2 by 2 by 2, 1, 1, and I know my middle is 1 square root of 3. This 2 is positive, it's a hypotenuse. This 2 is positive, it's hypotenuse. This one's negative, and this is negative. Okay, now cosecant is married to sine, and sine is opposite over hypotenuse, or even better, y over r. So cosecant, we're going to reciprocal. We're going to flip it upside down, so we're going to go r on top and y on bottom. So r is the radius, and the radius is 2. And on bottom, the y piece, and that's the vertical one, so it is negative square root 3. And times the bottom by square root 3 times the top by square root 3, and we should have 2 square roots of 3 over a negative 3. Again, I'll type them in. Type in cosecant of a negative 840 degrees. Type in 2 squared root 3 divided by negative 3. Make sure those decimals match up. Those decimals match up. You did it right. Last one, secant of 5 pi over 6. Okay, these are easy to count by. Because 180, a sixth of 180 is 30. So we're going to count by 30s, and 30s are way easy to count by. So we're going to go 5 30s. So we're going to go 30, 60, 90. So that was 3 30s, 4 30s, 5 30s, right there. Boom. So 5 30s is 150. And you're going to drop vertical, and I know that has to be 30. So I know that's 60, and I know it flips over the 30 and the 60, so my triangle is going to look like this. 2, 2, those are positive, positive. 2, half of it's positive. 1's positive, but this one is negative, and the middle is 1 square root of 3, and it is negative. Secant is married to cosine. Cosine is x over r, so we're going to reciprocal it. We want r over x. So I want the radius 2 over, this is the one we just barely did. X is a negative square root 3 times the bottom by square root 3 times top by square root 3. 2 square root of 3 over a negative 3. Okay, trig. You just got to solve the triangle. So the capital letters are angles. So 3 components are given. Angle C is given. This is angle A, so this is side A. So little a is 13. This is angle B, so this is little b. Little b is 8. So they give us 3 features, and we need to find the remaining. So we need to find 2 angles on one side. One side's going to be easy. Just go 8 squared plus 13 squared equals c squared. Use Pythagoras Theorem. That's going to simplify to a 64. 13 is 169. So if you add those two, you're going to get 233 is c squared. Now undo the square, square root, and 233 is probably not a perfect square, but they don't want it exact. They want you to round your answer. So now it's okay to come up with a decimal. So c equals, just go to the nearest tenth, 15.3. So c is 15.3. Okay, now the trig. The rest is going to be trig. So that's some geometry. And now let's do trig. So let's mark it 15.3. Let's mark it from here. If you mark it from here, that's opposite. That's hypotenuse, and that is adjacent. And we know all 3. So that means all 3 trig ratios are available to us. We can use any of them. So I'll use tangent. If I use tangent from that angle, so from angle B, the fraction for tangent is opposite over hypotenuse. And I know the fraction, I just don't know the angle. So I've got to undo the trig. I've got to inverse tangent. So I'm going to inverse tangent this side, inverse tangent this side, and I will have B equals inverse tangent of 8 divided by 15.3. That is 27.6 degrees. So I just found angle B, 27.6. And A and B have to give you 90. because C is 90, and 90 plus 90 is 180, and that's all there is in a triangle is 180. So I'm going to do 90 take away 27.6. So just do arithmetic to get angle A, 62.4. And this one you kind of draw your own triangle. You can even make it look just like the one on the left, ABC. Okay, little b is 0.06, so that's one feature. Angle A is 74.4.6. Angle A is 74.4. Angle C is 90. And okay, so they give us three features. Angle B is piece of cake. Just do 90 minus 74.4. And you got 15.6. 15.6, 90. Okay. Now, if I choose to mark it up this time from the A, so it doesn't matter what angle you mark it, just don't ever mark it from the 90. So if I mark it from A, that's opposite, that's hypotenuse, that is adjacent. Now I have to use adjacent because I know its value. I don't know the value of hypotenuse, I don't know the value of opposite, so I have to use adjacent. If I have to use adjacent, that limits my trig. This is not available to me because that does not even use adjacent, it uses opposite and hypotenuse. So I'm going to use this guy. I'm going to use, and it doesn't matter, if I use cosine, it will give me the hypotenuse. If I use tangent, it will give me the opposite. So I'll use cosine because I want the A to be on top of the fraction. So I'm going to go cosine from my position from the 74.4, and that is equal to adjacent. Oh, let's see. Goof, I messed up. Over hypotenuse. Okay, the hypotenuse is unknown, so we're going to call it x. So now look, I wanted, when x is on the bottom, that sucks. So I wanted it to be on the top. So I chose the wrong one. I should have chosen tangent, but that's okay. So if x is on bottom, let's get x out of the bottom. So undo divide x. So let's times x times x. That undoes. Now you got x times cosine of 74.4. So undo the times. So divide this by cosine of 74.4. And divide this side by the cosine 74.4. Okay. So now it's just calculator, just go 6 divided by cosine of 74.4, hit enter, and that should be 22.3 degrees. Let's see, not degrees, 22.3 inches or whatever they're measuring. So the piece we just found, we did cosine, so we just found the hypotenuse. So we just found this guy. This guy is 22.3 units long, and that is little c. So little c is 22.3. Oh, freak. So look, I'm looking at it, and 22.3 is super long compared to, that's 0.6, that's not 6. On my calculator, I did not type in 0.6, I just typed in 6. So look at your answer, and if it seems to be way too big or way too small, go back and check your work, and it's probably messed up. So I need to change this guy. This is a 0.6, so let's try this. If I do 0.6 divided by cosine of 74.4, there we go. It is the same digits, just the decimals moved over. So it's going to be 2.23 instead of 22.3. So 2.23, and then You can do a squared, b squared, c squared to find your third side, or trig. Trig is faster. So we're going to go tangent from the 74.4 equals opposite over adjacent. So now x is on top. So just undo the divide 6. Divide 0.6, so times by 0.6 times this side by 0.6. So you're going to go 0.6 times the tangent, 74.4. And that is 2.1. Okay, now use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So here we go. Your terminal side, your initial side is right here. That's where you start. Your terminal side, you're going to spin and stop. And you're going to stop at this point, negative square root of 5. So that's left square root of 5 and down 2. So it looks like you're going to spin all the way to right there, because it's going to go through this point. Now I'm going to do trig from this triangle right here. So if I go vertical and make a 90, I know this is a negative 2, and I know this is negative square root 5. If I label my triangle, this is the opposite, this is the adjacent, this is the hypotenuse, and you need cotangent. Cotangent is related to tangent, and tangent is y over x. So cotangent is going to be x over y, and they don't need this hypotenuse. So the x is the adjacent, the y is the opposite, the hypotenuse is r. So I don't even need to find the radius. If you do, you have to do a squared plus b squared is c squared. Cotangent, I just need the x on top. So that is negative square root 5. And I need the y on bottom, negative 2. And that's fine. Negative divided by negative is going to be a positive. So my answer is just square root 5 over 2. This point right here, negative 12, negative 6, is also in quadrant 3. So I'm going to go left 12, down 6. There's a point. So I am going to spin and stop until it goes through that point. So from that point, I'm going to go vertical, make a 90. This piece is negative 12. This piece is negative 6. And we need secant. Secant's married to cosine. Cosine is x over r. So now we do need the radius. So I'm going to do negative 6 squared plus negative 12 squared equals c squared. So that's going to simplify to be a positive 36 and a positive 144 equals c squared. And 36 plus 144. So we got c squared equals 180. Undo the square root, undo the square root. And does not say if they want an exact, but I'm going to say they do. So we want no decimals. We want it exact. So we're going to go square root 180 is pretty big. Let's pull the squares out of it. Square root of 180 divided by 10. So like 10 and 18. 10 is a 2 and a 5. 18 is a 6 and a 3. A 6 is a 2 and a 3. So I've got a 2, a 2, a 3, a 3, a 5. So I've got a 2 squared, 3 squared, 5, all under a radical. So the radical is going to undo this square, it's going to undo this square. but the 5 stays in. 2 is out, 3 is out. So on the outside, this is 6 square roots of 5. Okay, and we want x over r. So we want x, negative 12 over r, 6 square roots of 5. 12 sixths, these are going to simplify. That is negative 2 over 1 times the bottom by square root 5 times the top by square root 5. So my final answer, negative 2 square roots of 5 over 5. Okay, let's do these bottom ones. Find the sine of theta if the cosine of theta is 3/5. So you draw your own triangle. I'm going to mark it from here, so that's my opposite. That's my adjacent. That's my hypotenuse. And here we go. Cosine is adjacent over hypotenuse. So I'm going to put that as a 3 and that as a 5. And we need, let's see, adjacent's this guy. Okay, so I got the adjacent over hypotenuse, and we need the sine. Sine is opposite over hypotenuse, so I need this. And this is the most famous Pythagorean triple. I know it's just going to be 3, 4, 5. Because that's one of the rare triangles where all 3 sides are whole numbers, and if you don't recognize a 3, 4, 5, you could just go 3 squared plus x squared equals 5 squared. That's a 9, that's a 25, minus 9, x squared is 16, square root, it is 4. So the sine is going to be opposite over hypotenuse. The sine is 4/5. Okay, same thing. Sine, that's opposite, that's hypotenuse. So if I draw a triangle, I mark it from here. That's opposite, that's hypotenuse, that's adjacent. So that is 7, that is 25, and that is unknown. And they need cotangent. Okay, tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite. So I need the adjacent. So I got to do Pythagoras Theorem. I'm going to go x squared plus 7 squared equals 25 squared. X squared plus 49 equals 25 squared is 625 minus 49 x squared equals 576. And that is probably not a perfect square. Square root 576. Oh, sweet, it is. Square root, x is 24. So that is a perfect square. And we want adjacent, so we want 24 on top and opposite, 7 on bottom. 24 sevenths.